So now we get to talk about metals with variable charges and how to calculate those. So transition metals, except for zinc, cadmium, and arginine, um, that's a protein, yeah, anyway, form two or more positive ions, and these are called the cations. And the Roman numerals are equal to the ion charge, and that's placed in the parentheses immediately after the metal name. For instance, copper 2 would be Cu plus 2, where copper 1 is just the single charge. Iron 2 versus iron 3, lead 2 versus lead 4, chromium 3 versus chromium 6. Okay, so when we're looking, again, this is another one that might be good to print off, is some metals that form more than one positive ion and the charges that they have. So how do we use this to determine that variable charge? Well, we're going to use the charge on the anion and the charge to balance and calculate the charge on the metal ion. So for this one, the manganese has a +2. The F has a charge of 0. So how many are we going to end up having to have of the manganese to offset the -2? That's going to be 2 because it's 1 each positive, 2 positives plus 2 negatives equals a 0. So then that ends up giving you the manganese fluoride. So here are the ion charges. And again, this would be either this or that other table would be good to have by your hand for a little bit. So these are all +1, these are all +2. There are some in the middle that have +2s, right, 1, etc. And then these ones are -3, -2, -1. And then these guys are all happy because their orbitals are filled. So again, a great little chart to have by you while we're doing some of these calculations. So the guide, your step-by-step guide is step 1 is determine the charge of the cation from the anion. Step 2 is name the cation by its elemental name and use a Roman numeral in parentheses for the charge. Step 3 is name the anion by using the first syllable of its element, again followed by that "ide." And then step 4 would be to write the name of the cation first and the name of the anion second. So let's practice together and name the ionic compound for FeCl2. So step 1 is going to be determine the charge of the cation from the anion. And so our metal formula again is going to be FeCl2. So we have iron. So we have either the no charge, one charge, maybe one, so we have to do this, and then the non-metals here. And so those are our different charge options. And then we're going to name the cation by its elemental name and use the Roman numeral in parentheses for the charge. So iron 2, for instance. Okay, and then name the anion by using the first syllable of the elemental name by "ide," so that'd be chlorine, chloride, and then write the name for the cation first and the anion second. So that would end up being iron 2 chloride. Going back to that other one, this is how we end up getting out the iron 2, because the chlorine had the -1, right? And so we had 2 of those from the chlorine, so 2 -1s ends up being that we need 2 positive charge to equal that out. Okay, and so that ends up being how we get the FeCl2. All right, so here is one for you guys to check out. So name the following ionic compound containing the variable charge metal and MnO2. So pause me and come back. So determining the charge of the cation from the anion, we're going to analyze the problem, manganese, okay, and the we only have a balance of 1, right? 1 charge, where the oxygen, it has oxygen is -2 from that chart. Well, we have 2 of those, so that ends up that we have 4 negative charges. So then we'd end up having to have 4 +1s to end up equaling that double negative charge. Okay, And so you would end up naming it manganese because, again, we needed to have 4 of them. So it would be manganese 4, and then the oxide, so it would be manganese 4 oxide, right? So moving on, writing formulas for the name of an ionic compound. The formula for an ionic compound is written from the first part of the name that describes the metal, and then the second part that describes the nonmetal. And the subscripts are added to balance the charges. And so again, here are some ionic compounds of metals that form 2 kinds of positive ions. We have iron 2 chloride, iron 3 oxide, copper 1 phosphide, chromium 2 bromide, tin 2 chloride, lead 4 sulfide, and then bismuth 3 fluoride. Okay, so again, as you continue to do these, it becomes a lot more kind of standard, and it won't be as tricky. So the guide to writing formulas with the name of an ionic compound, again, is step 1, identify the cation and anion. Step 2 is balance the charges. Step 3 is to write the formula using the cation first, and then using the subscripts from the charge balance. And so here we go. So we're going to write the formula for iron 3 chloride. So analyzing the problem, what's the type of ion, the cation or the anion? The name is iron 3. Right? And then the anion would be chloride. What is the group? It's a transitional element. And so the symbol for iron is Fe3+. Chloride is from group 7A, and the symbol is Cl-. So what are we going to do? We have to balance these charges. We have 3 positives from the iron, and then that means that we're going to end up having to have 3 of the single 1 negatives to balance them out, because 3 plus 3 of the minuses equals 0, and so then that becomes the subscript. And so writing the chemical formula, then the cation first using the subscripts, and then the charge balance would be FeCl3. And so here's another one that you guys can write and practice. All right, good job. Okay, so to figure these guys out, we are going to use that handy dandy little chart, right? But remember that nickel has a +2 and sulfur has a -2. So then that would just be a 1-to-1. So then the chemical formula for that would be nickel sulfide. Okay, so that one was pretty easy. So then when we have zinc chloride, so remember that zinc has a +2, where chloride has a -1. And so you'd actually need to have 2 of the -1s to give you -2 to equal out the +2 to end up being 0. So then that would end up giving you zinc chloride, okay? Where your iron oxide, this guy, we have to remember using that chart that iron has a +3 and oxygen has a -2. So we have to have equal numbers, right? So if we times that by 2, then that ends up giving us a +6. And we times that by 3, and that ends up giving us a -6, and that'll end up giving us 0. So then that would be Fe2, because we had times it by 2. And then the O3, because we get the 3 here, to end up getting that 0 charge. All right, hopefully that was helpful. Thanks, guys.